Chalo. Chapter number 3, current electricity. Question is that write and explain Ohm's law. Ohm's law, it does not provide the resistance into the material. It just give you the characteristics of the material. This law gives you only the characteristics, means how much current is resist by the particular conductor or by particular metal. It does not provide you the resistance. Original definition of resistance is different. See, first of all, what do you mean by Ohm's law? First, under a certain physical condition, the law is that under certain physical condition, under certain physical condition, when current flow through two ends, when current flow through two ends of conductor, when current flow through two ends of the conductor and the potential difference between two ends of a conductor, this ratio remains same. This ratio remain constant. This ratio remain constant. Word to understand. Under certain physical condition. The condition is different. The condition may be different. Means what? It requires increase or decrease temperature. It requires increase and decrease the pressure. It requires magnetic field, electric field, and many more things are there. That are the certain conditions are there, that physical condition, due to which the metals or conductors behavior is different. So that named as under certain physical condition. When current flow through two ends of conductor and the potential difference between these two ends, this ratio remain constant. This ratio remain constant. What to understand this ratio remain constant means potential difference between two ends of the conductor. See, first of all, draw some simple diagram and understand what is that. Suppose this is the conductor. This is named as conductor. As we apply the potential difference here, that potential difference is V. That is the positive terminal of the battery. There's a negative terminal of the battery. So that is positive, that is negative. Okay. And the flow of current from positive to negative, from higher potential to lower potential, right? So that is the potential difference between two ends of the conductor and the current flow through this ratio remain constant. This ratio remain constant. Okay. So the equation is that what we say, potential difference between two ends of the conductor is directly proportional to I. That's another definition, is directly proportional to the I, because as you increase the potential difference, current is indirectly proportional, increases, and this ratio remain constant. So V is equal to I into R. Here R is constant, named as resistance, of conductor, maybe insulator also, because insulator have its own resistance. Here we deal with only conductor, that's what we named as a conductor. So therefore V upon I is equal to R. this ratio, the potential difference between two ends of the conductor and the current flow from that, is named as what we say Ohm's law. This is Ohm's law, and under certain condition. Now, what is the unit? Unit is voltage, unit volt, and current means ampere, which is equal to ohm. Its unit is ohm. That is its unit, and that is symbolically represented by this way. And also its dimensional formula that we have. Dimensional formula is M1L2T minus 3, and A minus 2 is dimensional formula, is its dimensional formula. So this is its Ohm's law. Need to understand under certain physical condition. That physical condition is vary from what we say understand pressure difference, temperature, then electric field and the magnetic field, anything is over there. So then current flow from that conductor and the potential difference, these two, this ratio of these two is constant, and that constant gives you the resistance. This constant gives you the resistance. What to understand this constant? So here is a constant, is named as a resistor, and this ratio is constant because suppose you take the 2 voltage, and according to that 1 ampere current is passed from that, this ratio is 2. 2 is resistance of that material is 2, right? So it gives you only the characteristics. What is original case resistance? It does not specify by these conditions. Only it is a constant represent in this Ohm's law. It gives you the characteristics of the material. It gives you the characteristics. Now, move further. The very next question is that what is electrical resistance? Now, the brain gets different questions to you. What is electrical resistance? What is electrical? What is electrical resistance? On which factor this resistance depend? On which factor this resistance value depends? And also explain how the resistance of the conductor depends on its dimension of the property, dimensions, and also different things are there, and find how these resistance depends on dimensions of a material, dimensions of material. That is electrical resistance word to understand. How this electrical resistance is depends upon its dimensions. Dimensions means what? It have a length, it have its mass, it have its radius. That is its dimension. That is its dimension. So first of all, do understand how this electrical resistance is depend. So for that, draw the diagram part. So first of all, draw the diagram part. So first of all, deal with the diagram part. Here we can understand the diagram part. Suppose this is the rod. Suppose here is this is the rod. Rod have some length. Suppose this is the rod, and this rod have some length, means it have length dimension, it have some volume dimension, and many more things are there. Right. So suppose the length here from here to here, it is length, and area of this is A. Area of this rod is A. Good. So first of all, from Ohm's law, one can understand V is equal to I into R. From Ohm's law, this is the main equation. V is equal to I into R, because we need to help this equation over here. At last, very last, not previously, but at last. Now, consider a conductor of length A. Consider a conductor of length A and length L, conductor of length L and have area A. Consider a conductor of length L, this is the length L, and having area A here. Now, if take the second conductor, if we take the second conductor here, so put the second conductor in front of this and second conductor in, maybe put it over here or cut this over here and cut it over here, right? So two things over here. So it is, take case number one. In very first case, take two conductor and join together. So I want to draw the diagram over here. Take two conductor and join together. So how it is looks like, take two conductor having same length and join together like this way. Join together like this way. Take two conductor over here. So how it is looks like, you see, just I put it over here. You see, this is the conductor. Just a minute, I draw. This is the conductor like this way, like this way. Okay, this is the conductor. Yes. Now join together like this way. This is the L distance. This is the L distance. This is the area A, and over here is also area A. You see, in case number one, if two rectangular block of conductors, they join by length to length, here two block of length L conductor join together as per diagram. As per diagram, these two conductors are joined together by length direction. So, and if you give the potential difference these two ends, now if we give current between two ends of the conductor, two ends of a conductor, these current value remains same. The value of this current remains same. This current value remains same. Means what? The flow from current from this end to this end remains same. It does not change. The value of this current remains same. No change in its value. No change in its value. And as you give the potential difference between two ends of the conductor, and the two ends of the conductor. Two ends of the conductor, potential difference is applied between two ends of the conductor. This is the current. There is no change in its current. As the two, as the potential difference, as the potential difference applied between two ends of the conductor, ends of a conductor is V. Means potential difference is applied between two ends of the conductor and the current value is remain same. Current value is remain same. What to understand? Current values remain same. But the thing is that here the length is 2 times. The length is 2 times. Properly understand. Here the length is 2 times. Sorry. Here is the length is up to 2 times. Properly guide to over here. So the voltage, what we say, understand, length is 2 times. So its resistance is also become 2 times. If length is 2 times, the resistance also become 2 times. Means it depends upon its what we say, its value, dimensions value. See how to understand. As the length become 2 times and as the length become 2 times, and try to understand the resistance also 2 times. Here is the resistor value is R. Here is R. In very first case, you apply the voltage. Over here is voltage V, then here voltage V, and then this. So voltage convert to twice V. Voltage convert to twice V, and but the potential remains same. Voltage value is twice V, but potential value, current value remains same. So what? Understand here, as the voltage, let the resistance of a conductor block, total block, let resistance value of total block is R1 total, which is divided into two part, divided into two part, and total voltage is twice V. So from Ohm's law, why it is so? Because try to understand, here the length is twice, L plus L, it having the length is twice, and due to this we can understand the potential is also individually V, and it is converted into 2 times. Addition, first block voltage is V, second block voltage is V, so V plus V is 2 times because we joined together these two blocks. So total voltage is V, but current remains same. As it flow from one place to another place. So from Ohm's law, R1 is equal to twice V divided by I, but V upon I is equal to R, because V upon I is equal to R. V upon I is equal to I. Get it this? So you understand the value of resistor R1 is twice R. It is converted to twice. But as the length, this is because the length is twice. To increase the length, double, triple, that much resistance also increases. It means that as the length increases, similarly Similarly, the value of resistance also increases. Value of resistance also increases as the length of rod increases. Similarly, value of resistances also increases. This means that R is directly proportional to the length. By this way, two blocks are joined together. So voltage is doubled, current remain flow same. Because over here, it is connected in series connection. Over here, the series connection. In series connection, voltage become 2 times. In series connection, voltage become 2 times. In parallel connection, voltage is same, but current makes a difference. Here is series connection. Right? So in series connection, resistance become double. It means that as you increase the length, similarly resistance is also increases. Means this resistance is depend upon the length. Dimensions of a rod is length. Resistance is depend upon the length. Resistance depends on length of the conductor. Length of conductor. Now, if I cut the length by area, then what happened? Then the second case previously is case number 1. Now this is case number 2. In this case, what we can understand? For that reason, I want to draw again the same rod, but I want to cut this rod in 2 parts. How I cut this? See, I cut this rod into 2 parts. I cut this rod into 2 parts. How? See, just I shift here to make the space to draw perfectly, and by this perfection I can understand proper way. See, this is the rod. See, this is the rod. This is the rod of length L. Yes, by this way. And now I want to cut these according to length, dimensions of length. You see, now I cut this rod by this way. Clear? So now you can understand from here to here it is length L. L remains same, but area become half. But what? As the length is cut, but area become half. So this area half, this area half, length remains same. So what to understand is, now cut the block into 2 equal parts parallel to length. See, now cut the block, according to its length, or along with its length, not according to, along its length, direction, make L same, but area half, area become half. When say by 2, length become same, that area is half. You see, area convert to half. Now you see, as the potential is applied to this combination between 2 ends of the conductor, and the current flowing through them is I. Each part, you see, as potential difference is applied between 2 ends of a conductor, as the potential difference is applied between 2 ends of the conductor, two ends of the conductor. So this potential value remains same. This potential value remains same as we deal with in a parallel condition. This is a parallel condition type. In parallel condition, voltage remains same. So here potential remains same, but value of current make a sense. Value of current is divided halfly in each part. Value of current, but value of current become half here, I by 2, and flow from each section. You see, half apart is from this section, current I by 2, but voltage remains same according to parallel condition law. Now, from this we can understand, from Ohm's law, you see, V is equal to IR, means R is equal to V upon I. Now, you see, take R2, voltage remains same, but value of current convert to half a value, to numerator side, divide by I, and 2 into R as this. And this R is from here. You see, V upon I is equal to I, V upon I is equal to this R over here. So in this condition also we can understand R2 is equal to R. In a previous condition also, it is twice R, sorry, it is twice R. And here you also see R1 is equal to twice R. R1 is equal to twice R means what? Length is doubled, so resistance is increases double. And but over here, as you see, half a value of area and resistance increases. By changing the cross section area, resistance become double. By this means by changing the value of a current, by changing the value of value of current. Understand? By changing the value of current also cross section area, current is also changing because half a value is divided. You can understand from here. By changing the value of area here, half, here it is A by 2. By changing the value of area, value of resistance doubled. So R2 is equal to time. In the case of area become half an area, resistance is this, and if you get double the area, double the length, resistance value same. So in both the case, resistance become twice. So one can understand R is proportional to 1 upon A. R is proportional to 1 upon A because area gets half. If area gets half, resistance become double. So this is the another equation. If area gets half, means A by 2 to numerator side. So twice R is that. So area is inversely proportional and length is directly proportional. Here area is inversely proportional and length is directly proportional. What to understand? Resistance is directly proportional. So the equation number 1. And here inversely proportional to the area, equation number 2. So in both the case we say from equation 1 and equation 2, we say what? R is proportional to length divided by area. R is proportional to length divided by area. Therefore, R is equal to rho L upon A. Here, rho is the constant, proportionality constant is equal to proportionality constant. Rho is the proportionality constant, which is nothing but resistivity of a conductor. Resistivity of a conductor or insulator, whatsoever, which of the object do you have, that is. So by this point of view, one can understand the resistors is depend value of resistor is depend length and area, length and area. So see once again what to do this. Here is a conductor. The question is what is electrical resistance? This is electrical resistance. V is equal to IR. This is electrical resistance. Okay, that is Ohm's law. But it is depend upon the dimensions. The value depends in dimensions of the material. How it is depend upon the dimension of the material? See over here. First of all, take a block of length A and area A. That is a one block of length L, area A. Now take another block and put it beside it, just like they are connected in series. So first of all, understand, as we provide the potential difference between two ends of the conductor, so what happened? First this block and then this block. If you provide individually to this, so voltage is value of voltage for first block it is V, second block it is V, so V plus V, it is twice V, because increase the voltage, but value of current remains same. As you see, the value of current remains same as the potential difference applied between two ends of the conductor. This V, so total twice V, but the value of current remains same. Just like this is the series connection. So if the value of current remains same, then one can understand, according to V is equal to IR, voltage is twice, and current remains same. What to understand? Length is double, voltage is double, current remains same. So V upon I is equal to R. So R1 is equal to twice R. R1 is equal to twice R. What to understand? R1 is equal to twice R. It means that as the length increases, similarly the value of resistance also increases. Length increase, so value of resistance also increase. So R is proportional to L. So resistance depend upon the length of the conductor. Similarly, in second case you see, now cut this block along its length or parallel to the length. Cut this block parallel to the length along with the length. So it divides, length remains same, but area become half. Length becomes same, but area become half. You see, half the area A by 2. As the potential difference applied between two ends of this conductor, now what? Voltage remains same, but current become half. Voltage remains same, but current become half, as it is the parallel connection. In parallel connection, what? Current become half, but voltage value remains same. Drop of the voltage value same, right? So the current become half. So V is equal to IR, R is equal to V upon I. So you see, current value become half. So we divide by I divide by 2. So 2 numerator side, 2 VI, V upon I is R. So in this case also resistance value become double, and in this case also resistance value become double. As the length increase, value of resistance is doubled, and as the length and the area become half, value of resistance also doubled. As the area become half, so resistance is inversely proportional to the area. R is inversely proportional to the area. R proportional to 1 upon A. So R is equal to rho L upon A. R is equal to rho L upon A. This is the main equation. So by this way one can understand that this is the original value of, or original definition of resistor. That the value of resistor is depend upon the length and inversely proportional to the area. It is proportionally called as rho is named as resistivity of the conductor. resistivity of a conductor. So it have a dimensions of ohm into meter or ohm into centimeter, right? So it have, one can understand, it have some dimensions. So therefore R is equal to rho L upon A. Therefore rho R A upon L. So unit ohm meter square per meter, 1 meter cancel. So ohm into meter. This is a unit. Unit is equal to ohm into meter. This is its unit, and its dimension formula, dimensional dimensional formula of resistivity of a conductor, MLTA, because ampere is there, M1, L3, T minus 3, A minus 2. By calculations, you obtain very easily. By calculations, you obtain these things very easily. So the definition of resistivity, what is the definition? So definitions of resistivity is that resistance of a conductor having unit length and unit cross section area is called resistivity or specific resistance. Resistance of a conductor, resistance of a conductor having unit length, and unit cross section area, is called resistivity of material or say conductor or insulator whatsoever, or say name specific specific resistance. This is its definition, because both the case unit length and unit cross section area is the unit length and unit cross section area. So that this is the part of the equation, that the value of resistor depend upon the length and area, Now second thing, second question is that what is the meaning of conductance? What is conductance? Its unit and its dimensional formula. So you can understand the reciprocal of conductor value of conductance value. The reciprocal of resistance gives you conductance. Reciprocal of resistance. Reciprocal of resistance is named as conductance. Conductance is equal to 1 upon resistance, the value of resistance, conductance. Here symbol of conductance represented by sigma, this. So sigma is equal to 1 upon R. Sigma is equal to 1 upon R. 1 upon R, sigma. Sorry, not a sigma part, conductance. Okay, no problem. Sigma part, you can have G, because another symbol is G. Conductance value is G. So 1 upon R is equal to G, and the unit is equal to ohm inverse. Unit is equal to ohm inverse. And dimension formula, as you see from here, or the what we say dimension formula ohm, and take the reciprocate, that is what we say dimension formula of conductance, dimensional formula is equal to M L T A, the what we say dimension formula of resistance. As you see previously, this is the dimension formula of ohm, value of resistors. So this M1 L2 T minus 3A2. Now take the reciprocal. I put it over here. Take reciprocal. Okay. Where I put? Yes, I put it over here. Take the reciprocal. So take 1, convert to -1 because it is numerator denominator side. Take L2, convert to -2. Take T3, convert to +3, and A minus, it is convert to +2, right? M -1, L -2, T +3, A +2, that is the plus. So inverse of this is this, correct? Inverse of this. So this is the, what we say, the conductance. With the help of this conductance, now the second question, as the inverse of resistance convert to conductance. So the second case also arises over here. What do you mean by, or say, what is the conductivity? Conductance, from it, conductivity. What is conductivity? What is conductivity and its unit? And what we say, its dimensional formula is that conductivity. So conductivity means what? The reciprocal of resistivity is named as conductivity. Reciprocal of resistivity is named as conductivity. Resistance of reciprocal of resistivity, and its symbol is sigma. So that sigma is equal to 1 upon rho. That rho is the resistivity. Reciprocal of resistivity is named as conductivity. Reciprocal of resistivity is named as conductivity, and its unit ohm meter inverse. Unit is ohm meter inverse. Means you see, this is ohm into meter. Inverse of this gives you the conductivity. Right? So dimension formula you obtain very easily from here. Dimensional formula very easily you obtain from here. M L T A. M convert to -1, L converts to -3, T converts to +3, A converts to +2. A converts to +2. Right? That is the conductivity. That is named as sigma. That is conductance. That is conductance. Get it? Now, the value of this conductivity depends on temperature also. It is too much important characteristic. This conductivity depends on temperature. On temperature. It is too much interesting point. Temperature, then pressure, then depends on material, which type of material we use, that is depends on that conductivity. Why it is so? Why it is depend upon a temperature? We later on we can understand. One question arise over here. In a dimensional formula, with the help of dimensional formula or dimensional consistency that we learn in 11th standard, chapter number 2, uses of dimensional formula. In that second case is that to understand dimensional consistency of any physical equation. So in that dimensional consistency equation, we can understand the left hand side of the dimensional formula is equal to right hand side of the dimensional formula. Then after we can accept any physical formula. In that physical formula, we can understand by that way. But when we understand the definition of that equation, it is something different, just like that. In previously, the definition of current, what you say in the definition of current, they say that current flow through any cross section area per unit time, the flow of charge from any cross section area per unit time is named as average current. In the definition, we can understand there is a area, cross section area, but when we write down the main equation, there is no area. Similarly, in this question, that conductivity or resistivity is depend upon the temperature. Resistivity and conductivity both depend on the temperature, pressure, material itself. But in this equation, there is no any temperature. So it means if you add the temperature over here, you gain something new equation from this. If you add something here, you gain the new equation. So that is that is the part of this chapter. That is so much beautiful chapter, because we can understand the new parameters over here, because we go deep dive into this chapter. Get it?
Yes.
Okay. આટલું જ કે પછી બસ?
આગળ ચાલશે.
કઈ નહીં, સ્ટોપ કરી દેવાનું.